Hello, I am Shyam Kota and I am here with Alan Boulding to talk about our new Zero Trust security architecture. As part of the overall architecture, we have some new innovations which Alan will be introducing today. To start, Alan, can you describe our overall security architecture?
Thank you, Shyam. I'm sure you have all heard about Zero Trust. But to level set, Zero Trust security overcomes the concept of a trusted inside network that connects to an untrusted network through a traditional firewall. As the name implies, Zero Trust assumes nothing should be trusted. It eliminates the implicit trust associated with network location and instead places the onus on continually monitoring all devices and applications for malintent. And then, if there is an indicator of malintent, it responds quickly.
If I can interject, what are the foundations of this architecture?
Well, the Arista solution is patterned off the NIST Zero Trust architecture that they laid out in the recently published framework. Our architecture leverages three fundamental pillars. One, situational awareness, which has everything to do with understanding all connected devices. Two, enforcement, which is largely about network segmentation to restrict lateral movement. Three, continuous monitoring to ensure devices are doing what they're supposed to be doing. The Arista solution addresses all three of these pillars. And once again, it is a model that does not assume trust and does not assume just because you are an authenticated good guy that your device somehow isn't infected. In a way, it's like saying, tell me who your friends are and I'll tell you who you are. Your behavior is studied, compared to your peer groups. And based on that, your situational identity, your intent, is evaluated.
As Alan mentioned, segmentation to control lateral movement and access is the core premise of enforcement. The requirements that drive segmentation are twofold. Control, who talks to whom or which entity, like a user or a device or application, and what can access which resources. And whether this be in the compute, virtual, or the storage domain. And the second one is audit, which provides a footprint or a trail of access of assets. These requirements span across data center, WAN, and campus. And the key business requirements that drive the need for segmentation can be found in all industry segments.
It is worth noting that as an industry, we have been doing various forms of segmentation for years with VLANs, VXLANs, VRFs, and even regular access control lists. What is needed is a scalable solution that decouples IP addressing from the ability to create policies that define whether a device can or cannot communicate with another device.
And those technologies still address the base use cases. Several years ago, we announced MSS, Macro Segmentation Service. We now have extended our segmentation capabilities across network domains with multi-domain MSS. As part of the Zero Trust security architecture for today's digital enterprise, Arista Multi-Domain Macro Segmentation Service provides a suite of capabilities for integrating security policy with the network through an open and consistent network segmentation approach across network domains. These are, number one, MSS Firewall, providing a security service insertion, allowing flexible placement of firewall policy across DMZ Edge, data center, and campus networks. Number two, MSS Host, a data center-focused solution where the security policies are extended from the virtualized host to the physical network. Now, I am particularly excited about a new way to segment called MSS Group. Alan, please tell us more about MSS Group.
Thanks, Shyam. MSS Group, well, as the name implies, is a group-based model where enforcement is done within EOS. It can work with third-party policy controllers, but unlike MSS Firewall and MSS Host, it can work by itself as well. And I'll talk more about just how in a moment. Just to quickly review, though, in a group-based model, all endpoints are placed into a group. In this simple example, all people are mapped into one of four groups: guests, employees, device admins, and contractors. Similarly, all the things and applications are placed into a group. An administrator then creates policies that define what group is allowed to talk to what other group. What's key in the group-based model is that there is a notion of a group ID, and all devices are mapped to a unique group ID. But what is innovative in the Arista group-based model is how groups are created and enforced, how policies are created that define inter, and for that matter, intra communication, and how the solution is independent from IP addressing. Being independent from IP addressing is just so important because one of the main problems with VLANs for group-based segmentation is that VLANs are mapped to IP addresses. If an administrator needs to create a new VLAN group, they may need to re-IP at least a portion of their network. And this makes using VLANs for granular segmentation impractical. In the Arista MSS group architecture, group tags are part of the forwarding ASICs. Every incoming packet is inspected in hardware, and both the source and destination security group ID is determined. As I mentioned, this is all independent of the IP address. As well, if the packet is switched or routed. Policy can also be created both within a group as well as between groups. For example, a camera can belong to the camera group and a DVR to a different group. Policy can be created that only allows cameras to talk to DVRs and not other cameras or anything beyond DVRs for that matter. Might sound simple, and it is conceptually, but vendors have been trying to develop scalable group-based segmentation for years, starting with VLANs, VLAN names, and other technologies. With other vendors, groups are created within ACLs. The challenge is quick exhaustion of TCAM resources as ACLs or groups scale. To overcome this issue, a leading vendor has adopted an Ethernet tagging approach. The Ethernet packet is modified to include segmentation information. While this approach addresses scale issues I spoke of, it makes the Ethernet frame proprietary. Consequently, the solution doesn't work well in a multi-vendor network, leading to the introduction of overlay protocols, which cause operational complexity and is not very practical at scale. But once again, the Arista approach is different. It does not modify the Ethernet frame. It is hardware-based, and the source and destination group tag for each packet is determined through hardware silicon lookup tables. Because this approach does not manipulate the Ethernet frame, upstream, downstream switches can be from another vendor. It simply works with any Ethernet frame. The Arista MSS group architecture has three logical levels: policy, orchestration, and enforcement. We just spoke of the new EOS and ASIC enhancements for enforcement, so I'll now talk about the other two layers. While the segmentation information can be programmed through the CLI or eAPI, for enterprise deployments where there are many switches, an orchestration layer is needed to ensure consistent policy. CloudVision provides this orchestration layer and ensures consistency as well as operational workflow. Very specifically, CloudVision is provisioning MSS group switches with security groups, what devices belong to each group, the policy of what group is allowed to talk to what other group. Devices within the same group can even be programmed to not communicate with each other, as I mentioned earlier in my camera example. While the orchestration layer is responsible for pushing configuration to the switch, it's the policy layer that is responsible for defining group definition, group membership, and policy. And as I show in this slide, CloudVision itself can provide the policy function when group membership is comprised of static IP addresses. But however, the MSS group solution is most powerful when CloudVision integrates with a dynamic identity layer. By leveraging APIs available in CloudVision, partners such as Forescout can ensure that different devices are put into logical groups based on device fingerprints, behavior, 802.1x, authentication, and other mechanisms. The APIs allow Forescout to associate each device with its relevant security segment group, and then apply the appropriate segmentation policies to CloudVision. As I mentioned, CloudVision is responsible then for orchestrating the provided policy to the various MSS group-enabled switches. And as new devices join the network or segmentation membership changes, Forescout automatically updates CloudVision with these changes.
So to recap what Alan just said, CloudVision is responsible for orchestrating groups, group membership, and policy. CloudVision provides the ability to create different zones of switches when not all switches share the same policy. And while configuration can be defined in CloudVision, it can also be integrated via an open API with third-party policy management systems. Arista's MSS group segmentation is a modern approach that helps IT teams to evolve the security framework from the current model to the one of Zero Trust security framework. This is accomplished by providing a tight integration between the network and security layers, consistent enforcement, and an open orchestration layer to integrate seamlessly to any policy engine. With evolving cyber threats, customers are looking for open, standards-based solutions to meet the new requirements around cloud, IoT, endpoint, mobility, and virtualization. Arista's approach to segmentation as part of the Zero Trust security framework provides the architecture to meet the evolving security requirements. For more information on Arista segmentation solutions, CloudVision, EOS, and Universal Cloud Networking, please visit www.arista.com. Thank you for watching.
Thank you.